Hello everyone, welcome to another episode of The Good Life. Now that we've started off 2018, we felt it was time to get back out there with some more interesting and hopefully some thought-provoking content for you. In this week's episode, we've got Charles and Gert from Montoux, primarily discussing artificial intelligence, in particular DeepMind. So they do talk quite extensively about AlphaGo Zero and how that game was able to overcome basically hundreds of years of thinking and specific strategies to win Go games in new and novel ways. So thanks for joining in and appreciate it and enjoy Charles and Gert's conversation. Thanks.
Just in the news as we are talking, it's like this last month is something, Google's DeepMind, and I don't know if you read it, but it is very spooky to read about it really, but computers have been able to be programmed to be very smart at very specific things, like a certain game, and 10 years ago they were playing chess. Probably 10 to 5 years ago, they were beating the world, Kasparov or whatever, at games of chess. Yeah. And then the next challenge was the game of Go, which is in computational terms far more complex because there are so many more different moves and it's even more strategic. There are more slots on the board. Yeah. So actually a program called AlphaGo, about 2 to 3 years ago, was able to beat Go grandmasters. And how that AlphaGo program worked was it was given, and I don't know the exact number, but let's say 1 million historical games of Go. Yeah. It just digitalized them and it knew all the moves in the whole game, and so it could build into its memory and thus its pattern spotting where the current game was in relation to 1 million games every time, and which games ended up with good results, i.e. wins, and which ones didn't. Yeah. And from that it could form its next move. And using that kind of technique, so it's really lots of example games, and it's a neural net really. Yeah, sure. It was able to beat Go grandmasters.
Yeah. Amazing.
Then what Google DeepMind did was said, okay, that's fine, but actually having to be bothered to look through 1 million example games every time, it took it a tenth of a second, that's not a problem really, of course, it can do it very quickly, that's the scary thing. Yeah. But let's see if we can do it a different way. So what they did is they created something called AlphaGo Zero, new computer program, and it didn't even really know how to spell the word Go, except that all they did was program into it the rules of Go, just the criteria. And then all they did was let this program, AlphaGo Zero, play AlphaGo. Yeah. And so there's one computer playing another computer, and it played itself about 1 million times over 2 days to learn some stuff. Yeah. Whatever it was doing, it was creating its own patterns, if you like, there, and spotting where it was winning and where it wasn't. And that took about 2 days, and then they ran it against AlphaGo again, and AlphaGo Zero beat AlphaGo, but had beaten grandmasters 100 games in sequence.
Amazing. So I'm wondering about that. When you said that the first AlphaGo was trained on 1 million existing games played by humans, I can imagine that the network picks up typical strategies and moves and patterns that are created by humans. But if you take this different approach, you might discover new ways of playing.
And when I say that AlphaGo Zero played AlphaGo 1 million times, it might have been 1 billion times, and of course 1 million of those could have been complete high-risk experiments, and 3 of them paid off, and suddenly that's a whole different strategy that it began to realize was worth remembering in its processing for a future time.
Yeah, amazing. The robotic football that I talked about earlier, that sort of project was set up specifically because they realized that computers playing chess is one sort of type of intelligence, very narrow, but you can also, run it on a computer with a screen and that's it. A computer or a human being running across a field and figuring out how to respond to a ball being kicked their way and kicking it in a very specific way and anticipating how other people respond to that. That's a different category, and it was set up because they realized that computer chess might be solved at some point, and this is the next step.
Yes. No, beyond what's narrow. So ANI, narrow artificial intelligence, AGI, generalized artificial intelligence. And then there is a view that there is something which is called superintelligence. And there's a guy called Nick Bostrom, is an Oxford University guy who's specialized in this. But it's really where the intelligence, and just is well beyond whatever we can imagine. And then when it can start improving itself in a computerized way, that the time frame that one might expect to get from AGI, the generalized intelligence, to superintelligence, everyone reckons when you think about it, it's probably that long. That's all. The computer working at speed will, once it can improve itself 30,000 million fold over in a tenth of a second, if you like, and it will just have gone through it, and it will have downloaded the internet into its own system, and it will have taken control of all the power supplies, because it will need to be conscious of threats to itself, because you do, if you want to flourish, you have to watch threats to yourself, and of course a human being turning me off is and it's doing it not for no maliciousness, it doesn't know what it's doing, but it's that short time frame that spooks me.